Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the heat of reactions. So what is the heat of a reaction? Well, the heat of the reaction is the total amount of energy that is released or absorbed during the chemical reaction. So delta H Rxn, or the heat of the reaction, is going to be the total amount of energy that is either released or absorbed during the chemical reaction. And the heat of reaction is equal to the sum of the energy that is released or absorbed by the products minus the sum of the amount of heat or energy that is released or absorbed by the reactants. Okay, so to calculate the total amount of energy of a reaction, it's simple. We have to figure out how much energy is released or absorbed by the products, and then we subtract the total amount of energy that is released or absorbed by the reactants. And when we're working with delta H Rxn, or the heat of the reaction problems, typically the heat of the reaction is going to be expressed in kilojoules, as well as the heat of the products. This will typically be in kilojoules as well, and the heat of the reactants will typically be in kilojoules as well. So if we use this formula along with what is called a heat of formation table, we can begin to calculate the heat of different reactions. So let's take a look at heat of formation tables next and see how they work. So what is a heat of formation table? Well, it says right here that a heat of formation table is going to be a table that shows the total amount of energy, typically in kilojoules per mole, that is released or absorbed during the formation of 1 mole of an individual compound. And it's important to keep in mind that the heat of formation for all elements is going to be 0. So a heat of formation table is going to show you the amount of heat or energy that is released or absorbed during the formation of these different compounds and molecules. For example, let's take a look at these two right here. Let's take a look at aluminum oxide solid, and let's take a look at HI gas. If we take a look at the formation of Al2O3, or aluminum oxide that's in the solid state, what this number is telling us is that for every 1 mole of this stuff that is formed, it's going to end up releasing, this negative sign means that it's going to end up releasing 1,669.8 kilojoules per mole of this substance made or formed. So for every 1 mole of this substance formed, it's going to release, because this sign here is negative, 1,669.8 kilojoules of energy. And if we take a look right here at this chemical reaction, we have the formation of HI gas. And so if we take a look at HI gas, what this is telling us is that for every 1 mole of HI that is formed, it's going to absorb 25.9 kilojoules of energy. And so because this sign here is positive, what that's telling us is that the formation of HI gas absorbs 25.9 kilojoules for every 1 mole of substance. And here in this chemical reaction we have 2 moles, so we can easily figure it out, or figure out how much energy the product here is going to absorb. All right, so we can begin to use this heat of formation table to calculate the amount of heat or energy that is released or absorbed during a chemical reaction. And it's important to keep in mind that elements always have a heat of formation equal to 0. For example, if we take a look at O2, elemental oxygen gas, we won't find that on our formation table because O2 is an element. It's one of the 7 diatomic molecules. It's elemental oxygen, and so we're not going to find that on our formation table. Same with hydrogen, and the same with iodine. These are both elements, right? They're diatomic molecules. They're one of the 7, and so you're not going to find these on our heat of formation table. They're 0. Okay, so the heat of formation of an element is going to be 0. So let's go ahead and apply this heat of formation table into 2 different example problems where we learn how to calculate the heat of the reaction, and then we learn how to calculate the heat of the reaction when we're given a specific quantity of a substance in the chemical reaction. In this first example, it says in the chemical reaction below, we need to calculate the heat of the reaction. So what we're asked to do in this problem is we are asked to figure out how much energy this chemical reaction is either going to release or absorb. And so let's take a look at this chemical reaction. What this reaction is telling us is that we have 1 mole of propane gas reacting with 5 moles of oxygen gas to produce 3 moles of carbon dioxide gas and 4 moles of water vapor. And what we're asked to figure out is how much energy is going to be released or absorbed during this chemical reaction. So what we're asked to figure out here is the heat of the reaction. And so in order to do this, we must have a heat of formation table, and you can get this heat of formation table on the internet or in a book, a textbook. This is reference material that will be given to you when you're solving these types of problems typically. And so to get the heat of the reaction, what we have to do is we have to take the sum of the energy that is released or absorbed by the products, and then subtract the sum of the energy that is released or absorbed by the reactants. So let's go ahead and do that. If we take a look on our product side, we have 3 moles of carbon dioxide. So we're going to write 3 moles of CO2. And we're going to end up multiplying this by the heat of formation for carbon dioxide gas. If we take a look right here, it's telling us that the heat of formation of 1 mole of carbon dioxide gas is negative 393.5 kilojoules per mole. So negative 393.5 kilojoules per mole. So there's this stuff right here is for our carbon dioxide, and now we're going to go ahead and add our water, right? If we take a look here, or our water vapor, we have 4 moles of water. And we're going to multiply this by the heat of formation for water. Now, when we take a look at this table, it's important to keep in mind we are dealing with H2O gas or water vapor. We're going to see 2 waters on our heat of formation table. We have to go with the one that says H2O gas. And it's telling us that the heat of formation for water vapor is negative 241.8 kilojoules per mole. So we just finished this part right here. We're figuring out the sum of the energy that is released or absorbed on the product side, and then we're going to do the same thing for the reactants. And if we take a look, we have 1 mole of propane. So we're going to take 1 mole of C3H8, and we're going to multiply that by the heat of formation for propane. If we take a look right here, negative 103.8, negative 103.8 kilojoules per mole. And then if we take a look, we're going to add 0. Why 0? Because O2 is an element. It's one of the 7 diatomic molecules on the periodic table, and oxygen gas is elemental oxygen. And the heat of formation for elements is always going to be 0. There we go. So we just set this problem up, and now we can plug this into our calculator. So we end up with, it looks like, negative 1,180.5 kilojoules plus a negative 967.2 kilojoules. And then we're going to end up subtracting a negative 103.8 kilojoules. Okay, so what this ends up becoming, on this side we have, or in these brackets right here, we're going to have negative 2,147.7 kilojoules, and we're going to subtract negative 103.8 kilojoules. And if we put this all in our calculator, we should end up with a grand total of negative 2,043.9 kilojoules. So that is our heat of the reaction right here. And so what does this mean? What does this negative sign mean right here? Well, this means that if we have this chemical reaction right here, this chemical reaction right here, this combustion reaction right here is going to release Anytime delta H is negative, it's going to release 2043.9 kilojoules of energy. And that means that this process right here is definitely going to be exothermic. And yes, in fact, all combustion reactions are exothermic. They release heat. So that's how we calculate the heat of the reaction. But what if we're given a specific amount of one of these substances here? How can we then calculate the heat of the reaction? Well, let's take a look at one final example. In this problem right here, it says in the chemical reaction below, calculate the amount of energy released or absorbed based on the consumption of 10.0 grams of calcium hydroxide. So we have a chemical reaction right here, and this is telling us that 2 moles of a hydrochloric acid is going to react with 1 mole of calcium hydroxide to produce 1 mole of calcium chloride and 2 moles of liquid water. So what we will first have to do is we're first going to have to figure out the heat of the reaction. That is to say, the amount of energy released or absorbed for this chemical reaction right here. And after that, we're going to have to figure out how much energy is released or absorbed based on only 10.0 grams of this right here. Okay, so this is a long problem, so let's jump right in here. First thing that we need to do is we need to figure out the heat of the reaction. And so to get the heat of the reaction, we take the sum of the energy released or absorbed by the products minus the sum of the energy released or absorbed by the reactants. So if we take a look at our balanced chemical equation on the product side, this is telling us we have 1 mole of CaCl2 and we're going to multiply this by the heat of formation of CaCl2. Let's take a look. Calcium chloride. Let's find calcium chloride here. It is negative 795.0. Negative 795.0 kilojoules per mole. And we're going to add this to the amount of energy that is released or absorbed during the formation of 2 moles of water. So we have 2 moles of water here that's in the liquid state. Times, let's find it right here, we have H2O in the liquid state, that's negative 285.8 kilojoules per mole, negative 285.8 kilojoules per mole. And so that is going to be the total amount of energy that is released or absorbed by the products. And so now we need to do the same thing with the reactants. Let's take a look here. We have 2 moles of HCl. Times the heat of formation of HCl. If we take a look right here, the heat of formation for HCl is going to be negative 92.3 kilojoules per mole. Plus, we have 1 mole of calcium hydroxide. And we're going to run out of room here. I'll just put the work right across this table here. So we have 1 mole of calcium hydroxide. And the heat of formation of calcium hydroxide, if we take a look, is negative 986.6. Negative 986.6 kilojoules per mole. So a lot of work here, but I think we have it. Right here we have the amount of energy that's going to be released or absorbed for the products. Right here we have the amount of energy that is released or absorbed by the reactants. And so now this is just a matter of putting this into our calculator. And we're going to have negative 795.0 kilojoules here, plus 2 times negative 285.8. We're going to end up with a negative 571.6 kilojoules here. And then we're going to subtract, it looks like, let's see, 2 times negative 92.3. And we're going to end up with negative 184.6 kilojoules here. Plus, let's see here, 1 times negative 986.6, which is negative 986.6 kilojoules there. put this into our calculator, and we end up with negative 1,366.6 kilojoules of energy on the products side. And on the reactant side, we are going to end up with negative 1,171.2 kilojoules. And so when we put this in our calculator, we will end up with negative 195.4 kilojoules. So that is our heat of the reaction. So it looks like this chemical reaction is going to release 195.4 kilojoules. We know it's going to release because the sign here is negative. So that is our heat of reaction. What we now need to figure out is if we have 10 grams of CaOH2, then how much energy will be released. So we have to carry this one step further. If we have 10 grams of CaOH2, we now need to figure out how much energy is going to be released based on this 10 grams. So we have to convert this to moles first. We know 1 mole of CaOH2 is going to be equal to 74.10 grams of CaOH2. This is the molar mass of CaOH2 from the periodic table. And then we just figured out right here, that 1 mole of CaOH2 from our balanced chemical equation, 1 mole of CaOH2 is going to be responsible for releasing 195.4 kilojoules. And so now when we put this in our calculator, when we take 10 divided by 74.10 times negative 194 kilojoules, we should end up with a grand total of negative 26.4 kilojoules. So a lot of work for this problem, right? We have 10 grams of calcium hydroxide in this chemical reaction right here. It's going to be responsible for releasing 26.4 kilojoules of energy according to this balanced chemical equation. So the first thing we did is we calculated the heat of the reaction, and then we had to set up a ratio based on the 10 grams of calcium hydroxide, which is a little bit less, or actually significantly less than the 1 mole of calcium hydroxide in this balanced chemical equation. So that is how we calculate the heat of reactions. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That's going to subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I hope you guys found this helpful.